So now we have angle relationships with triangles and parallel lines. So we're going to see a lot of the same things we saw with vertical angles, but it will look a little different in the diagrams. So the first one, we have a diagram of a triangle inside parallel lines. The lines that are at the top, A, E, F, B, and C, G, D are parallel. And then we have lines G, E, and G, F that create triangles on the inside. So we're given that angle DGF here is 32 degrees. We're also given that angle AEG is 137, and we are looking for this angle here, EGF. So we see that we have alternate interior angles here based off of our diagram that looks as such. So we're used to seeing two parallel lines cut by a transversal. So if you look at this here, we also have that same thing. We also have it over here. So what we know is that this entire angle here is 137. We're given that this is 32, and if we're looking for this missing angle here, all we have to do is subtract 32 from 137, and that's how we get 105 degrees. So what we have here for number 2 is two parallel lines with a transversal and a triangle created on the inside. So we know that QR is perpendicular to ST. So here's QR, and here is ST. Perpendicular means that they form right angles. So we have a right angle here and a right angle here. We're given that angle 1 is 3x plus 13 up here, and that also angle 2 is 5x minus 3. Right away, I can tell that this is 3x plus 13 here because these are alternate interior angles. It looks like the picture of two parallel lines cut by a transversal. We know that these two angles are congruent. So we have 3x plus 13, 5x minus 3, and 90 degrees from the perpendicular lines. So you see my work up here. If we add those three angles up, we can set them equal to 180 because of the interior angles of a triangle. When we do that and solve, we get x is equal to 10. Now that I have x is equal to 10, I have to find my angle 2. I do that here. I plug 10 into 5x minus 3, and I get 47 degrees for angle 2. For number 3, I have another set of parallel lines. So AB and DEF are parallel. And then I have lines that cut through it here. I'm given that angle B is 43 degrees and angle CEF is 152. And then I have to go ahead and fill off of that. So I have two angles along a straight line here. So therefore, I could do 180 minus 152 and get that angle is 28 degrees. I also have this angle 43 here because of the fact that I have the alternate interior angle up there. So remember, it looks like a Z. We have this cross here. We have alternate interior angles if you compare it to the picture. That's 43. Now, what I could do for this angle here is I could add them up to 180 degrees because we have the interior angles of a triangle. So I do 43 and 28, and then I have to get to 180 with this third angle. For the top triangle, now that I have that that's 109, we have this angle being 109 because it's a vertical angle. At the end of the day, we're looking for this angle here, this one on the outside. So right away, because I have the fact that this is 109, I have two angles along a straight line. 180 minus 109, this is 71 degrees. For number 4, we have another set of parallel lines, and we have a transversal cutting through as well as a segment creating a triangle. So for number 4 below, we have CBF is 42.5 degrees. CBF is 42.5 degrees. So here. There's my 42.5. I also have that BF and EF are congruent sides. So therefore, the opposite angles are congruent. I also have that CBF from the start was 42.5, which allows me to get this angle F here because they are alternate interior angles. Remember what our two parallel lines cut by a transversal looks like. Since these two sides are congruent, that means that I could subtract 42.5 from 180 like I did here, and then divide it by 2 to get these two base angles of the triangle. So therefore, angle EBF is 68.75 degrees. So all I did was I subtracted that 42.5 here. I had to make up the rest of this triangle. We had two congruent sides, so the opposite angles were congruent. So dividing by 2 allowed me to get those. Number 5, we have BD parallel to AE. So this line here and this line down here. AE and BD bisect CBE. So CBE is this angle. So we know that these two angles are congruent. So if this angle is 5x minus 2, this angle is also 5x minus 2. We're looking for angle A here, so this angle below. What I have here is I have corresponding angles. They're angles that are on the same side of the transversal. So if I have this, that would look like these two angles. So this angle and this angle here are corresponding angles. The first thing I have to do is set this angle and this angle equal to each other because they're alternate interiors. They're along that Z. So that would look something like this. We have alternate interiors. If I set those equal, I get x is equal to 4.5. Now, we already said that 5x minus 2 and 5x minus 2 were congruent because we had a bisector here. So now if I set those equal, I should get x. And then once I plug it in, I get 20.5. And remember back to this, that we had corresponding angles. So I get 20.5 degrees. For number 6, I had a similar diagram as always, the two parallel lines with a transversal line cutting through it. I have EF intersecting AB and CD at G and H, and GI is drawn so that GH and IH are congruent. So here's my GH and my IH labeled. Now, if EGB is 50 degrees, so this angle here, and DIG is 115, why are these two lines parallel? So the first thing I need to do is start off by proving that I have some sort of pair of congruent angles like we're used to seeing in this diagram like this, two parallel lines cut by a transversal. So we've seen alternate interior, alternate exterior, corresponding angles, those type of things. If we can prove one of those, we know the lines are parallel. So I'm able to get this as 65 because I'm given that this is 115. We have two angles along a straight line. So if I do 180 minus 115, I get 65 degrees. Now, since these two are congruent, the opposite angles are congruent. Now I have 65 degrees here, and also this is 65 degrees because they're alternate interior angles. So I just proved what I needed to prove to show those two lines are parallel. I proved that they are alternate interior angles and that they're congruent. 65 degrees settles both of them. So if we take a look at number 7, we have a triangle with smaller triangles inside of it. Now, the key piece of information that we're given is that angle M and angle O are bisected by the segments MS and OR. So that means these two angles are equal to each other, and then these two angles are equal to each other. We're started out by given that angle N is 40 degrees and that TMR is 28. So TMR would be this angle here. So right away, we can remember that this angle is bisected here. So that means this angle also has to be 28. Now we have to look at the big picture. This whole triangle, all of the angles add to 180 degrees. So if we have 40, 28 times 2, that would be 56. Our third angle up here will get us to 180. So 40 plus 56 gives us 96, and then plus 84 gives us 180. So this angle here is 84 degrees. And again, this is also bisected, so this would have to be 42 and 42. Now we have the smaller triangle to work with on the inside. We have this triangle here as such. So if I have 42 and 28, 110 would get me to 180. So 42 plus 28 would get me to 70. And then this angle here would have to be 110. So finally, I'm dealing with two angles along a straight line here. They both add to 180. That gives me my angle OTS that I'm looking for, which is 70 degrees. A lot of things to piece together there. So if we take a look at number 8, we have some parallel lines inside a triangle with some alternate interior angles, corresponding angles, bisectors, and maybe supplementary angles. So one angle is going to build off another here. In the blue, these are the angles we're given. We're given angle A is 82 degrees, angle AED is 64 degrees, and that DF bisects angle BDE. We're looking for the measure of angle DFC. That's this angle down here. So my step 1 is that angle ADE is 34 degrees, and that's because we're given 82 and 64, and we know that the interior angles of a triangle add up to 180 degrees. So our missing angle is 34 degrees because 82 plus 64 plus 34 gives us 180. Step 2, we're able to get that this angle here is 116, and that's because we have two angles along a straight line. When we have that, we have supplementary angles. So we do 180 minus 64, and we get that this angle here is 116 degrees. Now, step 3, we have corresponding angles. Corresponding angles are the angles that are on the same side of the transversal. So here and here, if you looked at that picture, it might not look exactly the same, but that's the situation we have. So if this angle here is 64, then this angle is also 64 because they're corresponding. Same thing goes on this side over here. We have corresponding angles at B. So we have angle B is 34, and we just found that this is angle 34, so those are congruent. Now, step 4, we have an angle bisector along a supplementary line. So here we have 34, and then we know these two angles are congruent because of the bisector. So if we do 180 minus 34, you see the work here, we get 146. And now we can divide that by 2 because of the bisector of two congruent angles. We get 73 and 73. And now in the last step here, the fourth angle in a quadrilateral gets us to 360. So we have this angle here, this angle here, this angle here. So we do 73 plus 116 plus 64. Add them together, we get 253. Subtract from 253, or subtract 253 from 360, and we get 107. So our missing angle, DFC, is 107. We really had to piece a bunch of angles together to get that one. And then at number 9, we have a diagram, again here, given multiple angle measurements and congruent sides. So if we look down here, we have BC is congruent to BA. Right away, we think isosceles triangle, the opposite angles are congruent. So we label that always, that's a habit. Now, we have missing sides, and we also have a missing angle. So in triangle DAB, angle D is equal to X. Angle DAB in that triangle is equal to 5X minus 30. And then angle DBA is 3X minus 60. And then in triangle ABC, we have the missing side is 6y minus 8 for side AB. And then we have side BC is 4y minus 2. So if we have to find angle BAC, or actually, sorry, we're on this one first, find angle D, we have to add up all three angles and set it equal to 180 because it's the interior angles of a triangle. So pretty straightforward. X plus 3x minus 60 plus 5x minus 30, we get x is equal to 30 degrees. Where x is equal to 30, we plug in, it's 30 degrees. For B, we're looking for angle BAC. So we just solve for x to be 30. Now we plug back to 5x minus 30, and we get 120 here. For C, now we're looking for segments. So if we're trying to find the length of segment BC here, this segment here, we set it equal to the other segment which we were given. So we do 6y minus 8 equal to 4y minus 2. We solve and we get y equals 3. Now we take this y equals 3 and we plug it back into side BC. When we do that, we get 4 times 3 minus 12. Side BC is equal to 10.